All right, welcome back to the scheduled program. I hope everybody has gotten their drinks. Next up on the floor, we've got, let me call on one of our lead DevOps engineer here at Leapfrog, Sparsha Dotel, who's going to be talking about automating your infrastructure, your best disaster recovery plan. So Sparsha, welcome to the floor.
Thanks, Kritika. Hi, guys. Okay, hi guys, welcome to Syntax 2021. Like Kritika mentioned, I'm Sparsha and I'll be your speaker for the topic automating your infrastructure. Starting a bit about me. So I'm a DevOps engineer here at Leapfrog. I have been working for around 4 years now, and my basic expertise, or like medium level expertise, lies with AWS, Python, containerization, and anything infrastructure as code. I'm a big fan of infrastructure as code, and I try and give that any experience that I have to my fellow team members. And I do apologize that the title of the talk is a bit misleading, which the title should actually have been my journey at Leapfrog and how my frequent fight with developers helped me, help better create an infrastructure, and in turn taught me a thing or two about being a half-decent DevOps who can actually create a disaster recovery plan. But that was too long, so just people that told me that not to put it in. So fighting with developers is basically not exactly a hobby, but situation of mine. I started as a DevOps, not as a DevOps, but as a system admin. So then there is always a battle of dev versus operations. Operations want stability, developer wants new change. And there's a wall of confusion because most of the time, not always, developer does not understand what operation wants, and what operation does not understand what a developer wants. So then there's always a friction going on. And then there's me, like starting as an associate software engineer, minding my own business. I'm learning my trade. I'm trying to launch a new Amazon EC2 instance that is new for me. And like, I thought I knew everything about it, right? Learning to install some Nginx, learning to install some Postgres, and then learning to install Node.js, then deploying a bit of React.js application. But then there was also understanding about how an SSH works, how a Linux file system works, and everything, right? So then I was learning that too. And then in comes a developer. He says like, okay, you have learned this, and this. Please deploy my code. Back then, I didn't know anything about deployment and automation and anything. So I just tried and deployed my code. But then there's the problem is, and it's always there, is it works on my machine problem. That I tried in deploying, it didn't work. So then I asked the developer, like, it does not work. And the developer answers, but well, it works on my machine. Well, then let's try another process. Well, then let's try CI/CD. So I didn't know much about CI/CD back then. So then I just heard about something called a Jenkins. I installed it and it worked. Like, it was awesome. Like in the 5th or 6th attempt, it worked, right? So now a bit of a pipeline was in place. You could actually do a monitoring of application by deployment of pipeline, deployment of applications, integrating it, running some tests, manual tests, and actually deploying it into an application. And I also heard about something called the Docker, that you could actually containerize your environments on this. So then I get an extra guarantee of stability, a containerized environment, and our automated code deployments. So those were the good old days. Then came in some bad old days. So I realized that our server limitations, especially initially Jenkins, could not handle 5, 6, 7 servers, 7 repositories, each having separate environments, and each trying to deploy everything at the same time. That actually does not work. Well, it does, but at one time it fails. And then there's frequent pop plugin upgrades, and then there's maintenance overhead for servers, right? There's EC2, you need to update an Nginx, you need to update a version of Node.js. And that's really boring. So then the developer asked, like, why not split it? Why don't you split your servers? It's easy, right? And I said, okay, yeah, it's easy. So then first, let's move our database. So we were using Amazon Web Services, then we thought, why not leverage an RDS? So then what we did is we just moved an RDS out of our EC2. We moved our database out of an EC2 to an RDS just to share a burden against application computation versus data computations. And it did work for a few weeks. Then there's another outage. And there's another suggestion that why not split out your app servers? We did that too. We split out the app servers from into two parts, right? And we kept a web server as an entry point. So now that web server acts as a static web app as well as a proxy, as well as a load balancer. So now in my head, in my unexperienced head, like I assume that, okay, this is it. This is the ultimate infrastructure. But then what we did realize is the web server could be a single point in failure, because everything goes through a web server, and outage of a web server to a client looks like outage of the entire infrastructure. So that's not right as well. So then, okay, we have already split out our database, our application servers. So then why not split out our web servers? Let's split everything. So then let's use a CDN. Well, an S3 bucket proxied by a CDN. And instead of a web server that was proxying to an application server as a load balancer, why not use an actual load balancer for once, right? So with that, did that as well. And that actually got us through for at least 2 or 3 months. But then there was a question, and never did I think about, what about security? How are you going to secure infrastructure? Why are you making your entire infrastructure publicly available? Now then, let's secure that as well. Let's put a VPC on top of it. So then what we need to realize is you cannot, the public facing things, like your load balancer and your CDN is public facing, that's okay. But your application servers and your database should not be public facing. So we just use that. Then you can add a security group, you can add a firewall, you can do anything you want, right? We did all of that. So then there's a complaint from a developer that, okay, you have actually secured it too much. It's an overkill, man. I cannot log into my EC2 instance, and I cannot view my logs. You need to give me a platform to view my logs. And then I was just irritated, right? Why don't you use a VPN? But then there was a bit of nagging and bit of, like I said, friction. And then we said, like, okay, let's set up an elastic stack. Let's use this as a logging server. But just using a logging server is not enough. You need agents. You need to put agents in each and every server that creates logs and sends that to a centralized logging server. So at least for Elasticstack, we found beats agents, preferably file beat agent. That file beat agent started sending out logs, and now the developer is happy for, I don't know, like 1 or 2 weeks. And then came another problem is there were some traffic and everything going on, and the website started getting slow. And he said, like, okay, now I want to view some monitoring as well. It's not just file logging is just not just doing for me. Okay, well then we still had an Elastic Stack. Well, then let's use that, right? So now with a file beat, we also added a new agent called metric beat that now starts sending the entire traffic of metrics from an EC2, from an RDS, everything that could be actually metricized, and starts sending it to an Elastic Stack. So now that means now you can actually view everything, right? So now I just asked the developer, are you happy? And his answer is, like, for now. And I said, okay. So then he asks, okay, I'm getting a bit tired of managing secrets and giving my developer secrets and using a .env file, and it's hard for me. Just make sure that get me some sort of a secrets manager. You know what to do, right? And I was like, okay. So then we just used AWS Secrets Manager for that. So now we had an option for the CI to grab those secrets during a build time. That's for any front-end applications. Or you could actually use that and deploy your backend applications and configure them, which in turn you could use those secrets in runtime. That's for your node applications. So now that's there. So now you had a KV store, you had a build time or a runtime secret consumption. Now things are like looking a bit more stable. The problem is now let's remove the burden of hosting our CI. Our application was all good and gone, but our CI servers started experiencing frequent outages. And you also need to realize that even though you say like Jenkins is free, but you are actually paying for it by hosting it. Like a good EC2 server would cost you around $200 a month, right? And so you are actually paying $200 a month that you need to manage it and guarantee its uptime yourself. So then why not let's go for a self-hosting CI. For now, we chose Circle CI. Back then we chose it because it was free for private repositories and we're in our comfort zone, so we didn't deviate from anything. So now we have a pretty decent architecture. We have now a Circle CI as a CI tool, CI/CD tool. We have the ability to deploy front-end and middlewares to their respective environments, and things are basically plug and play. Well, then we think about what about backups? So now you need to understand backups and why do you need backups? There's only simple one reason that you need backups is you don't need backups until you need backups. And we have learned it the hard way. Well, then, so then what do you need to backup? There's another question. Well, for now, there were only two things, data and application, because that was all there is to the server, but that was all there was to a server. So then you start to understand how do you back up a database. So then we had to do 3 levels of redundancies. One, database replication. You needed a standby database like a master slave to just be able to handle the load whenever a master goes down, if and when a master goes down. The other thing that you needed to do is you needed to keep a frequent snapshot of database so that you can actually, whenever any disaster, anything occurs, you could actually create something new and recover it. And to add an extra layer of redundancy, you also need a logical backup or an SQL dump. So then we were using RDS. So at least snapshots and replication was handled for us, because you could just enable multi-AZ and that's it. Both are there, right? But now look, for logical backups, you needed some sort of a cron job that actually does a dump and sends everything back to S3. For then we just chose an EC2, but that cron job server could be anything. You could choose a Lambda function, you could choose an ECS task, you could choose anything, and depending on your current infrastructure, you can modify it accordingly. So for our current infrastructure, things changed a bit. Everything was same, but now we had an extra layer of backups leveraging. So now you had a cron job server, an S3 bucket, and then you had 2 sets of Postgres, one master and one slave. So then, okay, we did work through our data backup strategy, but what about your application backup strategy? So then our application was hosted on an EC2 instance. So then we just thought, okay, we can just use snapshots, right? You just take a backup of a hard disk or SSD, create a snapshot, and you can actually create a CloudWatch job to initiate it and maintain it and everything. But then came a question. Do we really need an app server backup? Because in its core, what actually is an app server? It's an immutable thing that has a bunch of configurations, but it is only designed to run your application, to run your middleware for now. And that should always be treated as use and throw. So then we just thought like, okay, why not use an AMI, and why not create an AMI and clone that and launch that to an auto scaling group. So when you actually deploy it, you just create a new AMI of your build and update your auto scaling group, and then you actually run your infrastructure. That's easy, right? But then you just start thinking about, do you really need an EC2? Why don't you just move out of EC2? Because EC2 is a bit overkill in my opinion. Because you already have been containerizing your applications. Why don't you leverage an ECR as an Elastic Container Repository or a Docker Hub of Amazon, and leverage Fargate to manage your hosted app, right? And then use Circle CI to build your Docker image, push it to an ECR, and just ask your Fargate service to update it accordingly. And you could also configure CloudWatch to set up scaling, auto scaling, depending on the uses of your CPU, your RAM, or even your traffic, or even your time of day. You could do anything you wanted. So then we chose that one. So our infrastructure now looks like this. It's same, but different, but still the same. So now instead of an EC2 running Ubuntu, and which was in turn running Docker, we just used a Fargate container or Fargate service that was attaching itself to a load balancer. And then we leveraged CloudWatch service to actually auto scale it. Well, that's good. But then in comes another request, because we assumed that this is a great infrastructure. But the problem with that one is, well, I created an infrastructure, but now the team asked, like, create 3 more for me. What you did create is good for one environment. Back then it was just dev, but we're going into production in like 2 weeks. So we also need a production environment like that, and we also need a UAT environment like that. And then bit of cursing happened, and bit of, again, some friction happened, but we did do it. So now what you do have is same replica of 3 infrastructures. Each of them having one load balancer, a multiple of Fargate tasks, Postgres databases, S3, cron jobs, CloudWatch, Elastic, right? Everything. And Circle CI configured to deploy it according to the environments. Well, all that's said and done, but the thing is, the client asks, let's create a disaster recovery policy for this. Okay, then my first question back then was, what's a DRP, right? So then you answer like, okay, so disaster actually happens. So you need to actually plan for a disaster. Well, the actual process of planning a disaster recovery is basically these things. First, you actually need to understand what business impact analysis is. Like, what are the things that could possibly hamper your resources and that could possibly hamper your business, and what is acceptable and what is not. That is the actual driving force behind your disaster recovery plan. And then you need to think about 2 things, firstly 2 things. What's your RTO and what's your RPO? So RTO and RPO is basically recovery time objective. That means how long does it take to respawn a resource that was tainted? And recovery point objective is how much data loss is acceptable. So for your RPO, you could just say, like, if best case scenario, if you are using RDS, is 5 minutes. Like RDS says, like, it can actually check out at any point in time for 5 minutes, right? And your worst case scenario would be the frequency of your logical backups or the frequency of your snapshots. So if you, I would suggest, like if your RPO is 2 hours, then I would suggest that you do a frequent backups half the time. That is every 1 hour. And then you also needed to create a bunch of documents, right? With who the response teams are, how are you going to do a recovery strategy? And after you write all that down, you also need to do a maintenance and testing of that. So now that's a bit of a menial task. And we were extremely lazy for that, right? But we still did it. So then we actually had to understand each and every part of our hosted application, how that might break, and what was the disaster recovery policy or the procedure or the plan. So we created each and every one of them. Okay, but then the thing happens is one of our members who actually created this goes on a break. And then that day disaster happens and people start to follow the documentation. Now the problem is the DRP following those doing a manual process of and following the manual process of DRP is, first thing, people would assume that there would be a complete set of documentation, but there's never a complete set of documentation. Even if there is, or there was, there's so much or too much documentation, and it's not exactly on a simple steps, or it's not exactly handed to you on a plate. Do this, do that, do this, do that, right? That still requires a bit of an inspection, bit of an inspection. And then the other problem is, even if you do all this, and if you are able to follow the instructions, it's extremely slow process. Like if you are trying to do a disaster recovery for that infrastructure, my assumption is for each environment that could take up to 3 hours, 3 to 4 hours. So that's not exactly an enough, or like that's not an acceptable amount of time. That could be for some, that could not be for some. So that's the problem with manual disaster recovery, is incomplete documentation, too many things to look at, and an extremely slow process. So then the developer with whom I had a frequent quarrels asked me on questions like, why don't you guys automate and everything, right? Do a practice, like delete that everything that you could create on a Friday, relaunch it on a Monday, and just do a practice, do a manual practice, and be more efficient, be more like machine. And then you could actually speed up your process. Well, it's really irritating when someone asks a human to be a machine, right? But you could ask a machine to be a machine, because that's not a problem. So all what we had was, we needed a tool that just followed this requirement, is all your resources needed to be deleted on a Friday, and they needed to be provisioned by a Monday. Well then, all we actually needed was an automated process to provision and deprovision our infrastructure. So then we needed to choose a tool. Firstly, we had been using AWS, so we just thought like it should be able to handle AWS specific resources. Second thing, it should be testable. Whatever we do and whatever we write needs to be tested. It needs to have a testing process. And we were at that time 4 developers / DevOps, so DevOps. And we needed a tool that should be easy to collaborate, where all 4 of us could work together on it. And we would not have, well, not having is a far-fetched thing, but having less time of conflicts, that was necessary. So we had a bunch of tools. If you just Google it, these are the top 5 tools that you get, right? Chef, Ansible, Puppet, CloudFormation, and Terraform. Well, we actually started focusing on the bottom 2. So there was Terraform, like up and coming from HashiCorp, and there was CloudFormation, Amazon's very own infrastructure as code. But we chose Terraform. The reason for that was we needed a tool that was able to build, change, and version our infrastructure. That is there. That is basically infrastructure as code. Great. We also needed to create some execution plans, like plan before you apply. And we realized that it's really easy to write HashiCorp language instead of a YAML language. But it also gave you a better style of plan before you apply kind of thing. You could actually test your plan, you could actually plan your plan, and you could actually apply your plan. And you always knew that whatever you plan would always get done, nothing more and nothing less. Well, then what else did we need? We also needed a resource graph. We could write a bunch of code, right? You could say like spawn up an EC2 or spawn up a load balancer. And you could also say like, okay, create a Route 56 record whenever ELB is spawned and gets its public IP, and then create a Route 56 record with this domain accordingly. Now by saying it's easy, but actually doing a tool using any other tool, then that could create a bit of a dependency issue. But with Terraform, dependency graph came out of the box. So then it could prioritize one resource over another. So whenever I wrote anything regarding an ALB and Route 53, it made sure that load balancer gets up first and Route 53 gets up second, if those were related by any case. So now we did use that. And also what we also needed was a modular set of our infrastructure. We needed to follow a do not repeat yourself principle that was taught by each and every developer, and that was just thrown in our face. Then we needed to do that. And then we did create common modules for a certificate manager, a load balancer, a CloudFront, EC2, Fargate, RDS, you get the gist. But that actually created an easier collaboration across my team. And we were actually starting to get the hang of and even respect our developers a bit. And then finally, it's ease of use. Whenever you actually create a how-to document, right? You say like, do this, do that, do this, do that. But all you needed to do with Terraform was just do a plan and do an apply. That's it. Granted, you have access. Well, that actually started now a change in practice within our team and a change in mindset. First thing, we stopped using UI. Instead of actually writing or using the Amazon web interface and creating your any resources like a bucket, what we started using was doing a code, doing infrastructure as code. And whenever thinking about planning or thinking about changing and like doing everything and like just making sure that your bit of your mistake does not actually hamper your entire application workflow, like just updating your security group, what you could do is just write everything that you wanted and do a plan. And you could see like, these are the things that you needed to add, these are the things that would be destroyed, and see what could be destroyed, analyze it, and say that whether it's not actually applicable, that needs to be destroyed. So then other things, like instead of a manual provisioning process, you did a automated provisioning process. Now, being like a reactive team, we became more or less of a proactive team. And managing, doing an unmanaged thing of managing your infrastructure, like having a lot of dangling resources, like whenever you delete an instance, you forget to delete a volume, an attached volume or like a root volume. You might not have checked whenever you said like delete a volume, right? You actually now start writing a modular code for that. And with your infrastructure lacking documentation, lacking set of resources that was created, and if a client or anything that any new developer wanted to see, there is no documentation at first. But now your infrastructure as code is your document. And any complicated set of instructions that were needed to follow was replaced by Terraform and Terraform Apply. But the main thing that we did want and that we did was, and were able to achieve was, created ourselves a workable disaster recovery document. And that is my talk. Thank you guys. If you have any more queries, feel free to reach out to me at sparsha@lf.com.
Thank you, Sparsha. I really like the topic that you didn't go with, better than the one that you did. All right. So we have a few questions lined up for you, and we see a few coming in from the audience. Let me just pull up my consolidated list here. Okay. So my first question to you, Sparsha, is infrastructures are always being upgraded, and updating the code to maintain this infrastructure will be required. How do you manage the overhead time to update the code itself to keep up with the continuous change?
Well, I would answer it in a way like any developer would do, right? How would you actually update your code to keep up with the features, right? It's the same thing with our infrastructure as code. You could, you still need some time. It's not like you can do in this, right? You need some like a day or a week, depending on the amount of tasks that's needed. But that's all there is to it. You just need time.
Yeah. Okay. So the next question that I have for you is, if the execution of the code fails in between, will I have to manually roll back the executed changes and restart the entire code? Wouldn't this be a time-consuming process? If yes, how do I manage this?
Well, that also depends on the tool you use. Like if you use a Terraform, then the best thing that you have is Terraform manages states. So with states is basically a database to a middleware application. So state would be a database of the actual resources Terraform has already created and is yet to create. So if you ever face a problem, maybe a runtime misconfiguration, and you get an error, anything that has been created would always be created, and that would get updated in your state file or your database. And whenever you rerun, anything differential would only be created. So then that would not be exactly a time-consuming process.
Fair enough. The next question that I have you is from Prashant. With all the components, how does a novice DevOps not get overwhelmed, and how to plan and build in an incremental and scalable way?
Yeah, it's easy to get overwhelmed. But first thing is like just change your mind, like just keep it on your mindset that everything is new, and anything that you make mistakes, you are allowed to make a mistake. Granted that you do not repeat your mistakes, you're allowed to make a mistake. And then just start small, just start creating an instance or creating a S3 bucket and understand what that does. And then actually move forward. You cannot join DevOps and like tomorrow, like architect your entire infrastructure. That's really not fair to you guys. And that's not really fair to anyone, right? So that's how I would suggest you guys proceed through it.
That sounds like sound life advice as well. The next question
I
that I have
gotten that one from you though.
The next question that I have for you from Chumlung is, I want to start learning about DevOps, the DevOps aspect of development. What tools, services do you suggest me to begin with?
Well, Chumlung, you could just join our DevOps team, man. We are short-handed as is. But you could start with Terraform. I would suggest that you could start with Terraform. It's really easy to begin. If you just understand the components, what a 3-tier application needs, like a server, a database, and a server and a database. That's it, right? And if you just start creating that and launching that, and try and deploy your personal application to it, and just try and automate it, like started learning a Circle CI and do that. And you also do have a how to DevOps course plan, right? You could just check that out and just follow those steps.
Okay. So the next question that I have for you is from Sanjeev. What is the average cost of setting up a single instance of AWS Fargate with all the resources? Does the cost depend upon the number of users on the platform?
So by number of users, I am assuming that it's the traffic, right? So if it's set up as auto scaling, then yes, it does depend on the number of users. But let's say for a single environment, a load balancer would cost you around $22. a Fargate of a minimal Fargate, like a one CPU, one CPU and 2 GB of RAM would cost you around $20 to $30 per month, or 40, right? If you just auto scale it into 2 and set a auto scaling limit to 10, then it would cost you around $200, $250 a month. And depending on, but it's not like you are actually saying like your user base would be, let's say, 10 instances or 10 services handling 30,000 users. But you also need to realize that 30,000 users is at the peak time, maybe for 2-3 hours at max, right? So then you just say auto scaling group's rule to scale up and scale down, and that's it. Then you could be paying around $100 to $150 a month.
So with $200, you're saying that 3,000 at the peak hour traffic is sustainable.
If you architect and code well enough, yes.
Okay, there's a catch. All right. The next question I have for you is from Pratish. How do I deploy my app if I don't want to deal with anything DevOps? Something simple.
Pratish, you did write a tool for yourself, right? Shift. And you did let me take part on this. But you could use, there are so many tools that you could use, right? For like let's say just simple as serverless application deployment. You could use an up, or like let's just say like an up, or you could use for actual route, instead of a DNS thing, you could use Cloudflare. That's free for you guys. And you could also use something called Netlify.
True. Okay. If any of you have follow-up questions for Sparsha, please feel free to drop them in the chat. The next question that I have for you is from Anon. And the question is, what are the common problems you have encountered while migrating your infrastructure all the way from barebone EC2 instance to provisioning with Terraform?
Downtimes. That's the biggest problem that you need to mitigate. Like, just create downtimes and just making sure that how do you actually migrate your infrastructure during zero traffic hours. That was the biggest challenge. Like, if you say like you want to migrate your entire infrastructure in like 1.5 hours, because that was the time during which people were not using your application, you need to make sure that there is no deviation between the last snapshot of the data that you took and when you restored it. And you don't have to do a manual change in data, right? That was maybe one of the challenges that we are still facing.
Okay, thank you. On the same question, are there any specific do's and don'ts that you wholeheartedly believe that people should follow for that?
Well, the basic don'ts, right?
Mm-hmm.
Do's and don'ts is always remembering before pressing enter. This may get you promoted or this may get you fired. That's the first thing.
Amen.
The second thing is really, if you cannot roll back whatever you are trying to automate it, do not automate it. That's the second thing. And the third thing is just keep on learning and keep an open mind. It would be an awesome thing that to be proven wrong.
That sounds like sound advice. The next question that I have for you, Sparsha, is from Ashim Kharka. How do you replicate data between multiple database instances?
So are you talking about active clusters, or like just active passive clusters? Okay, active, right? So even with active, you have like 3 options, right? Basically 3 options are read local, write global, read local, write clustered, and read local, write local. I will suggest you actually refrain away from doing read local and write local. That causes a lot of problems for you guys. And read local and write global was basically causes a bit of a latency whenever you actually face a disaster. But then read local and write clustered, that is That would be your actual goal. Cluster your databases accordingly. If you are using microservices, just split that out into multiple databases. You could even split out your data between regions, right? Maybe if you are doing a multi-region, multi-database for a multi-region application, just split your traffic, application traffic and application data for people who are in those different regions. For, let's say, if you are creating a sports application, right? A sports betting application, let's say. People in India, and I'm not trying to be any racist or anything, but people in India would basically be interested in betting in cricket sports, whereas people from England would be more interested in betting in a football sports, football, right? But then what you could do is set your database cluster for football, like let's say football betting in England, and set your database cluster for football cricket betting in India. And then replicate India's do a master slave replication for India's cluster in England and England's to India, crisscross. That could actually help you.
Awesome. So the next question that I have for you, Sparsha, is from Praneen Shakya. Would you elaborate a bit on how a graceful shutdown procedure would work during a typical tear down operation?
First thing is comms. Communication should always be open. You should let know of all the parties that are involved, like the client, the PMs, your product owners, and everyone. And also, if it's a client-facing application, communicate it through social media channels, like a GitHub would do, or even GitHub would do. Like we're saying, like we are going down for 30 minutes to 1 hour for during this time, and the application won't be usable. Sorry about the inconvenience. And then shut down all the application, but most importantly, remove the traffic. So what you could do is you could reroute your traffic into an S3 bucket. So any traffic that comes into your system gets rerouted to a maintenance page, and people cannot do anything about that. And that would be the easiest process.
Sounds good. The next question that I have for you is from Jagat Jyoti. Can you please discuss an instance when serverless cost exceed server cost?
When you don't actually recognize the volume of the traffic that serverless can get. For instance, Lambda, I think it's around free for around 1,000 hits per month, right? And after that, it actually gets extremely expensive because it's a pay-as-you-use model. Mm-hmm. And if you suppose forget to actually update your costs or update your, basically, if you say like you want a Lambda instance with 4 GB RAM, right? If that's the case, then and what you are doing is you're planning it for a data pipeline. Let's say a new file comes in an S3 bucket. You do a CloudWatch thingy that actually spawns a that actually spawns a Lambda instance, then which actually again spawns an ECS task. And so then you think like, okay, we are getting a velocity of like 2 to 3 files a day. That's still okay. That's still feasible. But maybe the guy or the person that is actually sending you the file decides like knowingly or unknowingly to send you 20,000 files at that time. S3 is scalable, so is Lambda, so is the ECS. And then you actually start spawning 10,000 Lambda processes and 10,000 ECS processes that actually now creates 10,000 connections to your database. So not only you are actually paying a lot, you are actually hampering your system.
Okay, I hope that answers Jagat Jyoti's question. If not, you can add a follow-up on the chat. The next question that I have for you is from Raj Maharjan. As for the learning part, was the problem solving with different with the developers and iterative that is finding solution for that problem when it comes around, or is it requirement that we need to have with the job?
That actually, that's an interesting question. I wouldn't say that it might be a requirement, but what you need to understand is it should be a culture that's ingrained within any company that you're working in. Collaboration is always the best answer.
As simple as that. Seems like Praneen really enjoyed your answer and your build-up in the slides. I see a lot of other questions here in the chat. One question that I have for you is, what are your thoughts on building our own server instead of relying on AWS? Is it scalable? This comes from Lucky Shrestha.
Well, yes. Yes and no. Well, you can scale it as much as you want, but you have to pay for it. And you're not actually paying for your hardware. Hardware costs are always cheaper than AWS. I admit that. But you have to you have to have a maintenance guy, right? Mm-hmm. So then how much are you paying your maintenance guy? 30,000 a month, 50,000 a month, 80,000 a month, 100,000 a month, just to maintain your infrastructure. Well, then with that case, and if you can reduce that costs, then I would suggest, yeah, you could do a self-hosted infrastructure. But then else, I would say, like, just go for AWS, man.
So the scalability comes more from the cost factor and the amount of time you would want to invest.
Yeah.
Okay, awesome. The next question that I have for you is from Prabhat. If your production data is in RDS and development is in EC2, how do we create a plan for seamless backups from both saying we don't want to use RDS backups for production?
So if you just want to do a logical backup, that's okay. PG dump or MySQL dump works on both. But you still need to have a backup client, a backup taking client, and that's there. And as for EC2, and if you want to do a, let's say, a snapshot thing, right? Instead of doing an RDS snapshot, you would still do an EC2 snapshot. As for replication, you can still create your own replication server, but that again requires a bit of a maintenance overhead. But that's also possible. For like Postgres, you do have a PG wall writer, and you could just leverage that and manage that accordingly.
Okay, Prabhat, if you want to add follow-ups, please go ahead and leave that in the chat. The next question that I have for Sparsha is like the shortest question on here. Azure or AWS?
AWS.
Would you like to elaborate?
No. No, okay. Actually, so AWS, when I did start, right? So there was a change in, or a difference in philosophy. Initially, AWS was designed as IaaS, or infrastructure as a service. So then AWS was designed to create whatever you wanted that you could create on your local infrastructure, you could create on AWS. Azure was designed as platform as a service. You could host anything you want on your infrastructure. So with just that in mind, I think AWS has way too many features to explore. That's why
Okay. I see Subhash Paudil in the chat is very passionate about Azure. And we've got Bibhushan who's asking, what about GCP?
Same thing. GCP is still great. If you're doing Kubernetes, I think GCP would be awesome, right? It has a bit more Kubernetes with GCP is a very exciting opportunity, but I would still say AWS.
Okay, and I guess Mahesh agrees with you.
Thank you, Mahesh.
The next question that I have for you from Prajwal is, can you please let me know your thoughts on what is DevOps? Is it a culture, a practice, or a standard?
Ideally, it should always be a culture. That's what I believe, and I'll continue to believe. But that does not mean that it cannot be a position as well. It could be a position, and you could. What I do see is like a progression, right? Initially, it becomes a standard, which in turns converts it to a practice, which in turns converts to a culture.
Fair enough. The next question that I have for you, and this comes from Sujan Maharjan, is could you please elaborate on ERS and Fargate?
ERS, okay. Elastic Repository, okay. ECR, okay. Okay. So that's all. The simplest way of putting it is, if you do understand Docker, right? Just assume that ECR is your Docker hub and Fargate is your Docker compose. Does that answer your question? Kind of. So ECR is like a image registry where you can actually push an image. When you actually build your Docker image, you can push it to an ECR. That could be leveraged across anything, right? You can pull an ECR image, like you pulled it from Docker Hub to your local instance. You could pull it to an EC2. You could pull it anywhere. Fargate is just one of those platforms that actually pulls an ECR Docker image. That could be from an ECR, that could be from Docker Hub, anywhere, right? And it just runs, and it can run as a task, which is use and throw model. It runs, it opens up, it does a service, and it stops. It does a task and it stops, or as a service model, something like an API, where it actually keeps on running, sets all kind of auto scaling rules, and it can attach itself to a load balancer. Load balancers target groups and actually do your API hosting.
Sujan, I hope that answers your question. If not, you can. Okay, got it. Awesome. The next question that I have for you, Sparsha, and this comes from A. Subedi, Mr. Anonymous, is in case of the microservice architecture, how do we take backup with state in given time if there are tens of servers?
I actually don't understand the question.
Tens of state, perhaps. The text says servers. I'm assuming it might have been a typo, but A. Subedi, if you're in the audience and if you would like to elaborate. While he does that, let me pull up the next question. This comes from Gaurav Shrestha. I have deployed a Node.js and React app to AWS EC2 and used to SSH-I into it with a PEM file. Is that the ideal way?
Yes. I would assume that you're just using an EC2 for. Is it a big project or a small project? If it's just a medium scale, okay. So you need to understand about vertical scaling and horizontal scaling, right? And it has its own pros and cons. If you think like it's still okay, it's not bad. Let's just put it that way. But what you do need to maintain is, if you are hosting your Node.js application and your React application, which user is hosting it? Is it an Ubuntu or a root user? If you are hosting it with a root user, I would suggest not doing that. Create a semi-privileged or an unprivileged user that could actually host your application. So yeah, if you are using with and hosting your Node.js application with Ubuntu user, no, I meant like Ubuntu user.
Okay, Gaurav, if you have any other follow-ups, please feel free to drop them in the chat. The next question that I have for you, and this comes from Nirjal Paudel, is how to get into DevOps being a full stack. I know the basics of Linux, shell, and scripting. Is database engineering a part of DevOps?
It helps to have a knowledge about databases, but no, it's not a requirement to be part of DevOps. If you are a full stack engineer, you could just begin by running your applications that is not on your local computer. Just run it maybe in your friend's computer, maybe on your own servers, right? And start by making sure that it runs anywhere. That would be a good entry point.
The classic run it on your friend's computer first. Reminds me of the early 2000s. All right, the next question that I have for you, and this comes from Prakash Prajapati. Why are you not using Kubernetes and creating your own scalable infrastructure using Fargate? P.S. I don't know much about Fargate though.
We are. That was just a simple demo of a single project or a multiple project that I was experienced in. We are using Kubernetes in AWS. We have not yet gotten to using it with Fargate. We're still using EC2s with auto scaling group. Sorry, we're a bit slow on that perspective. But yeah, we are.
Building on top of that specific question, we get another one from Pratik Manandar, who asks, could you give a short comparison with pros and cons between using Kubernetes and Elastic Container Service, since they're both container-based services?
Yeah. So Elastic Container Service on its own is a hosting service. Kubernetes is an orchestration service. So what I mean by that is, if you give Kubernetes access, it can leverage an RDS for you, an EBS for you. It can leverage Route 53 records for you. It can leverage load balancer for you. So whatever you plan and create on a Kubernetes cluster, and if it has a permission to access those resources, it can provision those resources for itself. That's the biggest difference between Kubernetes and ECS.
Okay, awesome. So it looks like Mr. Anonymous is back with us and he's corrected the sentence for us to make more sense out of it. This comes from A. Subedi. In case of the microservice architecture, how do we take backups with state of application in given time if there are tens of services of each application?
Well, if you are doing so if you are doing a stateful backup, right? Mm-hmm. So then you need to make sure that those states, if they are not in the database and they need to be stored somewhere, that thing needs to be backed up. And if you want to do a RPO or like point in time recovery, then you need to maintain backups in that exact amount of time and make sure that those things are not lost. Or you can even leverage PubSub module, right? Any, like, let's say inter microservice communication, instead of doing in a file, you could just use like a Redis cluster or Kafka or even like a RabbitMQ, right? And just make sure that RabbitMQ gets backed up.
How'd you do that?
The normal way. You just use the same thing. Like if you are using managed services, just make sure that if you're hosting on an EC2 platform, just make sure that that EC2 is getting backed up. And if you're using on any other service, just look into that and see how the backup works.
Okay, awesome. Thank you, Sparsha. So we've got time for one last question for Sparsha, and this comes from his AWS supporter buddy, Mahesh. What do you think about Pulumi? Will it replace Terraform in the future? Pros and cons.
I'm actually sorry to disappoint you, Mahesh. I actually have not used Pulumi. I would look forward to learning it from you, though. Would you teach that to me?
All right. So that concludes all of the questions. Mahesh, feel free to reach out to Sparsha. I'm pretty sure his social handles are somewhere in the Leapfrog, Instagram, LinkedIn spaces. So you can, or you can reach out to us at LinkedIn to, send that question to Sparsha, or